Okay, now it's recording again. Now for the next one here, someone tell me, what's the initial value going to be? Someone?
3,900.
Very good. 3,900, right? That's what we get, because that's the number in front here. Now do we have growth or decay though? Well, we have decay. And how do we know that? The base, 0.95, right? I think the book also calls it the growth factor. This is less than 1. So we have that. So that's decaying. That's 0.95. Okay? Good. All right. And now how do we get R? Well, since it's decaying, we have to have 1 minus R is 0.95. But how do we get R? You just solve for it. I know I didn't show the calculations here, but it's very similar to the calculations on the first slide. So to get R, you just have this. It's basically you're going to have 1 minus 0.95 and R is 0.05. So that's basically what's happening here. Okay. And this is what I was trying to say in the second slide. You can actually come up with an exponential function, okay? You can come up with an exponential function. Namely, what you can do is you just look at the parameters here. So for instance, the initial value is 1,000, right? It's decaying, and the rate is 0.11. So the exponential function will be 1,000 times 1 minus 0.11. Again, the initial value is 1,000. We want minus because we want it to decay. And R is still 0.11. Growth, well, the initial value is different, but for growth, though, the only difference, well, the difference there will be addition. So in other words, for growth, okay, we're going to have this. 1 plus 0.11. So basically, what am I saying? This is actually done in the book as well. If you have certain parameters, like you want the function to decay, you want the initial value to be this, and you want it to decay at a certain rate, which is this is a decimal, you could easily come up with an exponential function like that. That's what I'm trying to say. Okay, that's good. Now, last time also we did an example with more explicit calculations. I want to do that here. Okay, so I want to do that. I think it'd be good to do because I felt like last time it went kind of a little, how do I say this? The lecture, it was okay, but it was good, but it could have been better. But I want to do another example like this. So we have f of x now is 10 times 0.25 times x. Okay, well, again, just like before, we can get our initial value. Remember, that's what a is, right? So that's 10. Okay. We have our b, our base, right? Since that's less than 1, R must be of the form here. So we must have 0.25 as 1 minus R. But then you can just solve for R. I mean, I didn't show calculations, but you can solve it algebraically. And you end up getting 0.75. Okay, 0.75. And that tells us as a percent, our decay rate is 75%. Now, what does that really mean? Well, calculation-wise, these are just some calculations I did with, I think actually I did it with Excel, Microsoft Excel, right? This is our function, okay? This is the input, this is x, this is the output we're getting. And notice right away that you can see the amount of change in the function is not constant. For a linear function, it would be. Here, however, it's not. What is constant is something like this, for instance. What this is saying is the relative change from between f of 0 and f of 1, that is negative 0.75. So as a percentage, what this is saying is the function value is decreasing by 75%. So you're taking 10 and subtracting off 75% of that to get f of 1. Likewise, to get from f of 1 to f of 2, you decrease by 75%. So you take 2.5, subtract off 75% of it, and you get f of 2. That's what this is saying. Then to get to f of 3, you subtract off 75% of this to get f of 3, and so on and so forth. And so on and so forth. Okay, so again, this was just, I think someone, it might have been the other class, they asked about like what was actually constant, or they had a really good question. I don't remember what it was, but I remember it was a good question, and that's why I'm just doing these calculations. That's why I'm doing this. Okay. Okay. Pause this. Okay, let me just pause this, and I want to ask something.